Good day, everyone. I trust you all are in good health. So, my name is Shalini, and I extend a warm welcome to each one of you for joining this informative webinar on empowering your predictive maintenance strategy with Qritrim, expertly presented by Suman. So, before we begin, I want to emphasize that your questions are highly encouraged. Please use the Q&A section to submit your queries, and we will address them after Suman concludes the agenda. Now let's start with a brief introduction to Qritrim. So Qritrim is a leader in artificial intelligence, domain intelligence (ADI), driving Industry 4.0 transformation through innovative AI solutions. So central to our mission is a cheap platform designed to make AI accessible to organizations of all sizes. So Qritrim solutions are rooted in ADI principles, including predictive maintenance solutions, AI powered insights, data integration and analytics, factoid solutions, electrical diagram extraction, and etc. So each of them is designed to drive efficiency, reducing downtime, and providing valuable domain specific insights to clients across various industries. So, and here is the most exciting part. I'm delighted to share that Qritrim has recently earned a remarkable recognition by securing two prestigious awards at the Confederation of Indian Industry CII National Competition. We have been honored with a gold award and a predictive maintenance category, and we have secured a silver for electrical diagram extraction. So definitely these are reflecting our dedication and expertise in these domains. So to learn more about Qritrim, please visit our website and social media platforms like LinkedIn, Twitter, Insta, and Facebook. Without further ado, I'd like to introduce our distinguished speaker, Suman Rawuri, the co-founder and chief architect at Qritrim, has joined us today. With over a decade of experience, he excels in building high performing teams, managing complex projects, and staying at the forefront of technology. So, he is renowned for his compassionate and innovating leadership style, benefiting both teams and clients in the age of digital transformation. Now, we are eager to see like what insights Suman has in store for us today. So, welcome, Suman. The floor is yours, and on to you.
Thank you, Shalini. Good morning, good evening to all. Hope you're having good health. Uh, I'll get straight into the agenda. So, as part of this presentation, I'll be going through these five important topics here. So, I'll be covering the predictive maintenance. So, what is the predictive maintenance and its essence of it? Then, how Qritrim will be useful, how Qritrim empowers your maintenance strategy. Uh, then we'll also cover how predictive maintenance helps different industries and the use case around it. Then we'll also talk about what advantages or what is that is different for the Qritrim predictive maintenance solution. Why we claim that we are better. Then after that, we also cover what we are planning to do beyond this predictive maintenance. After predictive maintenance, what do you want to do in future around predictive maintenance? Okay. So that's what I'll cover. I'll get started here. So before we understand predictive maintenance, let's understand what is happening about the current market situation. Um, so what's happening? Okay, this is a Siemens report. So this is a recently published report from Siemens. This data is from there. Uh, what is happening over a period of time? Uh, the number of instances of a downtime or a number of instances the downtime machine is down or a particular plant is down is reducing significantly, but at the same time the cost of downtime is increasing significantly. Okay, it's really growing exponentially. Okay, so that's where you see that a cost of downtime, if a production plant is down for a hour, the average loss for the company or average cost for that downtime is $2 million per hour. Okay, this is the aggregated number from Siemens report. The next is that yearly loss, primarily in the Fortune 500 companies, is $1.5 trillion just because of the downtime. Okay, so if overall industry is losing this much of money because of the downtime, and still, even though that number of instances of down emissions are not working well or plant is coming down is reducing, still unplanned downtime is at 1.6 million hours in a given year. So it's a huge number. Okay, and most of the companies on average they're running at a efficiency of 70%. So we would like to target at 90%, if not 100%, but the average OP is at uh, 70%. So OPE means operational overall productive production efficiency. Sometimes people call as equipment efficiency also, but we call it a production efficiency. Primarily, it not only equipment, it encompasses many other aspects. That's why we call it the OPE. So what are all the factors that contribute to OPE? Okay. So the factors that contribute to OPE is that primarily the availability. That means the availability score 100 means a process. A process can comprise of a single machine or it can be a multiple machine, and it's always running during the planned production time. Okay, so it's not happen that we plan something and it is down. Okay, so if you plan something, it should work. So that's 100%. Then performance score means it is running as fast as possible. That means we are supposed to produce 5 items for a given process. Are we producing those 5 items, or we are producing only 4 items, or we are producing 3 items? If you're producing 5 items, you're supposed to produce 5 items in a given time period. If you're producing the five, that means you're 100%. Otherwise, based on the number, the percentage will come down. The next is quality. So quality means once you produce the products, whether the products are being accepted 100% or certain parts are failing. Okay? So the quality score 100% means no defect. So only good foods are being produced. Okay. So the OPE is a multiplication of these percentages, these numbers, availability versus availability multiplied by performance and quality. So so it's not just only about mission. It is about mission availability and mission performing at an optimal level and producing the good quality products. So, so goal is to make all three factors better to increase the current OPE. So if you're aiming for 90, so we need to focus on all these three areas, okay? Not just on only on the mission availability. Uh, so this is a general, I can say, a stage of the maintenance in your company. That means if you're at a level one, means you're doing a reactive maintenance. That means you do not have any maintenance strategy. Okay, so you only fix when it is broken. Then the planned maintenance, so scheduled maintenance activities. So most of the people in the world already adapted here. That's where you see that the average OP is standing at 70%. So 50 to 70% means a planned activity. Then some kind of proactive planning. This is primarily with the help of expert advice. Um, People will foresee certain errors and they'll try to fix upfront. This is mostly manual involvement is high, and that too we need a people with a high skilled manual involvement. Okay? So this is a bit costly, or it is a maybe this cost is continue to run for a longer period of time. Okay? So this is there to some extent. Then the next is the predictive maintenance. Okay? So the predictive maintenance is where we put advanced analytics, we put AI uh, to determine the error that is going to come, and by analyzing the sensor data, this is the predictive maintenance. So this is what we are going to talk more here. So if you are aiming average OP is 70% in the world, if you are aiming for 90 plus, so the predictive maintenance is the way forward. Okay. So as per the data, mostly I think a lot of companies, some companies have already adopted the predictive maintenance, but a lot of companies need to adopt the predictive maintenance. That's where we see the opportunity here. Okay. So production efficiency, there is a slightly a misnomer that people focus on only just equipment efficiency. But what we feel that it is a production efficiency means equipment efficiency, again a quality efficiency. So how do we achieve quality efficiency? That is through process predictive maintenance and equipment efficiency through equipment predictive maintenance. So both we should happen. So we should continue to monitor the equipment and we should continue to monitor the process also. Entire production line also needs to be monitored. Example, uh, in a given product line, we have two machines. Uh, so from one machine, certain data needs to go to the machine two. So if that is supposed to take only 3 minutes to send the data to 3 minutes to send the machine to intermediate product to the machine two, but if the system is taking 4 minutes, With the second machine may not have enough time to process it. That may be a challenge. So that's where maybe a quality of the outcome will be deteriorating. So that's where we will watch entire process, entire product line will be monitored. That's where the process predictive maintenance comes also into picture. Okay. So due to paucity of time, I'll be more focused on the equipment predictive maintenance, but the Qritrim has a potential or a implementation for the process predictive maintenance also. So now we understood what is predictive maintenance now. So what Qritrim offers? So why, what is that Qritrim has as a platform offering in the from the predictive maintenance perspective? Okay. So Qritrim is a primarily a platform. We built a predictive maintenance solution on top of Qritrim. So Qritrim inherently comes with the certain features. So Qritrim allows you to prepare the templated solution. So for predictive maintenance, you already have a templated solution. All you need to do is that take that templated solution and modify for your need. So you don't need to build from scratch. The second is Qritrim offers you a configurable solution. So again, if you know, if you're good in data engineering concepts, or if your team is good in data engineering concept and ML concepts, you do not need to end up writing a lot of code. All you need to do is that drag the open the web application, drag the items here and there, and modify, put the configurations, and the system will start working. Maybe if you have a good ML engineer and data engineers, their productivity will increase significantly. Then it also supports multi-source data like MQDT, SCADA, and image data, because different companies will have a different data sources. It also supports. Then system is auto scalable. That means if you produce pipelines, if you prepare pipelines, if you produce models, those models will scale dynamically. So they can, okay. So I'll cover these things big detail in the coming slides. So here is the Qritrim templated solution. So for predictive maintenance, already we have a PDM for welding machine available. If you have to modify, all you have to do is simply drag and drop, add one more example. You want to add one more block. You can just choose the black and add one more product line or some other feature that you can do it. Or if you want to delete it, you can also delete it. So simple, just click on this button. You'll be able to delete that. It's about a very simple configuration. So based on your need, you can understand the existing template. You can remove certain blocks. You can add certain blocks. Very simple. Okay? So that's the advantage of template solution. You don't need to spend a lot of time in doing something from scratch again. Then we'll go to the configuration part. So Qritrim is primarily configuration driven. So when you see, this is the high level flow that prepared we got from the template here. So for each block, again, it's a configuration driven. If we go inside, so again, this is the data that can be, you can have these building blocks dragged. Okay. So people can configure the properties here. So say primarily for S3 ingester, okay, if the data is available in certain path, you can configure it. So you can configure certain classification algorithm, and you can configure the parameters around it. Uh, you can do a time series forecasting, and you can serve this as an API. Okay. So these blocks are kind of connected. You can connect one block to another block. It's again a simple selection and dragging and dropping into the target building block. Okay. So purely configurable, and all the parameters are given such a way that if you know the concepts, you can, all you can do is that you can go and configure and test your application, test your pipeline. Okay. See, these are the properties. Then it also supports a multiple data sources. So the data can come as an image. Data can be in the form of MQTT data, or it can be a SCADA data, or it can be OPC data. Okay. So it supports multiple data sources. Apart from the things that we mentioned here, it also supports the data from standard data source like S3 ingester, some relational databases, some big data. Okay. But I covered only very high level. So here also these data sources, you can take from the template, whatever template may give one data source. Maybe you can remove that data source and you can add your own data source and configure the columns around it. Okay, so pretty easy and configurable. And Qritrim's PDM is also scalable. The architecture inbuilt for the scalability. So, so let's say initially you have a mission and you can put a pipeline here, and the pipeline is feeding the data to the model, and model is doing some kind of prediction. Okay, this is a typical case here. That means the data comes from the equipment, and uh, data ingestion pipeline reads the data and invokes the model. Okay, uh, now if a machine is producing more data or you have more machines, all we have to do is that to scale them. Okay, so it can scale like this. So the scalability is inbuilt, and even through certain configuration, even you can scale this for multiple production lines also. Okay, so it's not a single production line. You can take multiple production lines. You can copy slightly, because one production line may be slightly different from another production line. Okay, you prepare one solution for one pipeline, production pipeline. You take that other template and use it for the other production line also. So that way scalability is uh, inbuilt in the system. So now we talked about the Qritrim, what Qritrim offers to you. Then we are going to the where what are all the areas where predictive maintenance is useful. So in a very simple terms, predictive maintenance is useful wherever you are uh, producing something, wherever there is a production line, wherever you are combining multiple raw material or converting a single raw material into other uh, finished product. That's where predictive maintenance is useful. So it's useful in manufacturing, oil and gas industry, food and beverages, power and energy industry. So again, as Qritrim has uh, implemented a template-based solution, all we have to do is that take an existing template solution and modify as per your specific domain or specific industry or a specific use case. Okay. So in manufacturing, you can have different types of missions. Missions can be boiler plate, boiler steam, quality control, compressor pump, HVAC system, tooling and dyeing mission, whatnot. Any kind of mission that can be monitored, and we can do a predictive maintenance here. Then the food and beverage system, you can apply predictive maintenance for refrigerator systems, conveyor belts, baking equipment, duct mixture, extruder maintenance. Okay, different types of missions. For each kind of mission, we can apply the predictive maintenance, and for each product line also we can apply the predictive maintenance. Again, in oil and gas industry, uh, again, it's a different industry, but has a different kinds of missions there. You may need to monitor the rigs. You may need to monitor pipelines. You may need to see the drill corrosion detection. Okay. Sometimes you need to watch the tank pressure monitoring. Okay. So a lot of uh, but different missions, but the concepts are the same. Then the power and energy. This is thriving industry now because slowly people are moving towards the electricity. With the power and energy, it can be a gas turbine maintenance or wind turbine maintenance, or it can be even nuclear plant equipment maintenance. Okay, you can have a transmission line maintenance also. Okay, so it's all like wherever you have a predefined procedure and a set of equipments, we should be able to apply predictive maintenance there. Okay. Then comes to the Qritrim's PDM edge. So what is that? The Qritrim is different. Qritrim's predictive maintenance solution is different. How it offers a better value compared to other solutions. Okay. So primarily Qritrim predictive maintenance solution is defined as a combination of three things, because our system is designed or implemented to do three things. Okay. So first it predicts the failure. So it goes and tries to predict the failure for a given equipment or in a given for a given process in a given production line. Okay. Then after predicting the failure, it also determines the root cause. And for the determine the root cause, based on the root cause, it also recommends the solution also. Okay. So the advantage with the solution is that you may not need to have expert all the time available, because what I observed is that many solutions are stopping at a prediction and leaving it to the people to decide the root cause and recommend solution. So that's the advantage Qritrim is providing. So here, it's a very high level what we are doing. So you may have a question how we are doing uh, the root cause detection and recommendation. That's where this domain knowledge is useful to us. So what we do, we feed FMEA, mission FMEA documents, process FMEA documents, mission documents, and certain mission attributes like repair cost, productivity loss, PPM, yield, MTTR, MTBF, all that information we feed into our domain knowledge, and that domain knowledge is fed into the models here. Okay. So again, the models, we have a master model because that master model comes from the Qritrim platform. And on top of this model, we can build a prediction model, root cause model, recommendation model. And the input is a sensor data and waveform data and a knowledge data and a maintenance report. So combining maintenance reports and sensor data, we produce some kind of label data that allows us to uh, uh, do the real proper prediction. Then root cause and recommendation primarily focus on the domain knowledge. So once you have the prediction and that data is available on the predict and error interface. So this is primarily available for the managers of the uh, production company. And it's also has some kind of expert user. So expert user can see that whether this error is a false positive, or maybe error prediction is right, root cause may be wrong, or recommendation may be wrong. He can put that feedback eh, into the expert feedback system, and that feedback system feeds the data back to the again domain knowledge as well as to the model. Okay. So that's how we have covered uh, all the gaps, and finally we this solution is fully covered all the aspects of the predictive maintenance. Again, for a domain knowledge, this is what we've done. Uh, that okay, there is FMEA and there's a mission document maintenance reports. These are all fed to the knowledge builder, and knowledge builder builds the knowledge base, and that is the input to the predict module, and again a predict interface. So what is that we've done differently in the prediction model? Okay, this is also we want to do something different. So what we've done, rather than going for a single model, we went for a hybrid model here. So because time prediction, predictive maintenance expects you to go for the hybrid model because it's not a single solution. You need to combine two different algorithms. So we need to have a time series one to know the time to failure, and we need a classification algorithm to tell what is a possible error it will fail. That means the car may fail because of lack of engine oil, or maybe some challenge in the gearbox, right? So error classification is also important. This is how, because if we get a proper error classification, then we'll easy for us to identify the root cause and the corresponding recommendation also. Okay. So, and it's easy even for the people also to take the remedials also. So what we've done, we have done a transformer mode approach. Okay. So we have taken a time series data. So we have all the sensor data coming in the time series. Then we did apply a positional encoding on top of it. Uh, and then we did a attention module. So this is a multi-headed attention. And then we kept a fully connected layer uh, on top of it. Uh, Then we did flatten the layer because we want to apply some kind of activation function. After flatten layer, then we applied the ReLU activation function. So this is one aspect of the neural network. And as it is a multi-headed attention, query key value calculation happens, and finally we decide the final score. Okay. So the reason why we went for the transformer approach is because the transformer has the attention where we will be able to keep the data. Example, we will have a bigger context of the window. Example, if I have a sensor data for a current minute or a current millisecond or a current second, if I try to do a predictive maintenance, the possibility of a prediction will be most likely less. But if I can keep the window for for last 1 hour, or for last 2 hours, for last 3 hours, then the possibility of predicting the error will be a better. So that's where we have decided to go for the transformer here. Then once the transformer is able to detect the time to failure, that means when it will fail, it is predicting the future event. Then again, the same time series data is being sent to other transformer, and this is primarily to do the error classification. So we apply the transformer, and finally we are applying like softmax to classify that this is the most probable error uh, for the error classification. Okay, so this is the hybrid model that we have built. Uh, this is giving a pretty good results compared to the a pretty standard regression based uh, predictive maintenance, or maybe regression based time to failure, okay, or remaining useful life. Okay. Now the thing is that, okay, we have this predictive maintenance working now, but what is the future? Okay, what is that we are thinking from the future perspective? So what we visualize, and certain work is already being done in this direction. That is combining the predictive maintenance with the digital twin. The digital twin is a popular technology uh, that is taking a lot of adoption now. Maybe one example most of you can correlate is that the Indian Prime Minister uh, Narendra Modi was able to uh, drive some vehicle from the remote location, right? That is the extreme, or maybe the best example for the digital twin, okay? Because he has a replica sitting here and he was able to operate from here, and it is acting in the different location. But in this industry or manufacturing or industry 4.0, primarily digital twin is that creating the replica of a equipment as well as the entire product line. Okay, so that's what, when you have the digital twin and when you combine with the predictive maintenance, we expect that it will be a potential game changer. We can bring even the efficiency close to 100%. That's what we foresee. So we have some comparison. What the challenges that we are facing in the predictive maintenance, how it can be solved, or how digital twin based predictive maintenance can help. So these are the things. So primarily equipment simulation. So it is a static simulation. That means you have a, a single view based on the given configuration. But in case of a digital twin creation, you can have a dynamic simulation. Okay, so you can have a higher possibilities. You can say, okay, what happens because you don't need to physically do anything with the machine, but with a digital twin, you can do a dynamic simulation. Okay, you can give a different parameter to the equipment and start seeing how that equipment will behave. So the dynamic simulation will help you to produce a lot of data, which is primarily useful in doing a better predictive maintenance solution. Okay. That's what even maintenance data also, it's insufficient data. Because one of the challenge that we're facing in predictive maintenance is that uh, the errors that come, let's say if a mission runs, uh, let's say for 24 hours or maybe for a month, most likely the failures will be maybe one day in a month, and the downtime may be 2 hours because of that. Okay. As I told you initially, that the number of instance of a downtime is reducing, but the cost of downtime is increasing. The problem is that the instance of downtime is reducing, so we are not getting a lot of input data to try and predictive maintenance models. Okay. Uh, Sometimes even errors happen, but as it is a manual activity, people are not recording the data, then we do not have the data. But if you go with a digital twin, so digital twin is a replica of the real production machine. So the data is automatically and naturally collected. The data is readily available, stored in the digital twin itself. Okay, or storage systems associated with the digital. So this data is available, and the combination of dynamic simulation, you can produce more data also. And second is a maintenance timing part of it. So in the standard predictive maintenance example, we go and predict that this machine is going to fail in next 3 hours time because of the lubricant is getting thickened. Uh, but we are not telling that when to do the maintenance. Okay. So again, that is leaving it to the expert decision. But here, when you go for digital twin will be able to accurately tell you based on many other parameters. Okay, that means, okay, other production line, dependency on other production line. Because we have entire system digitalized, So you'll be able to put a real-time data analysis, and you can have the maintenance timing decided uh, more accurately. Okay. Even the data utilization part also, the low effective utilization and predictions are one-sided. Primarily, here's the challenge is here the challenge is uh, because whatever the data that is recorded, uh, that is enabled for the recording, only that part is being stored. So that mostly data is one-sided because this is expert decision what data to be consumed. But when we put a digital twin, we have ability to use all data and we can do in-depth analysis. Then again, maintenance efficiency. So again, if there is a change in the equipment, if there is a change in equipment behavior, our predictive maintenance systems find it difficult to adopt. Okay, so it's very vulnerable for the equipment changes. If there is a significant change in the equipment behavior, even predictive maintenance solutions will also struggle because that was not given as an input. But as we have a digital twin in place, because with a dynamic simulation, you can even simulate those kind of environments as the data is produced. Even this real-time changes also, we'll be able to accommodate little faster and quicker. And the data reserve, because right now the data production is mostly a manual activity and you have to put sensors and the stuff, uh, as, as that they're producing some kind of data and some part of data, there is no uniformity across different companies. That's why they're not sharing at an enterprise level. uh, we do not have an enterprise level fault data. But if a digital twin comes, we hope things will be more streamlined. Uh, so that there is a possibility that enterprises can also share, which is very much beneficial because if particular company shares their failure data in a common pattern, other companies will also benefit, and it's a mutual beneficial thing. Okay. The next is the model fidelity. That means how close uh, the predictive maintenance model is close to the real mission. It is uh, better than many previous aspects in terms of manual maintenance or planned maintenance, but is relatively poor compared to the digital twin based predictive maintenance. The model will be much more closer and represents the real equipment. Okay. And apart from all these things, the fault prediction accuracy will also increase, because one of the challenge that we face is there is a possibility of many false positives coming in. The way we are solving in the current predictive maintenance is that as we put that expert feedback interface, users give the feedback. Okay, this is the false positive. The next time system will learn, and it won't repeat that mistake again. But with the digital twin in place, it will have a further improvement. So what we see as a future, that if we can uh, put a good alliance together between a digital twin and predictive maintenance, it is going to be a very good solution. It's going to be a potential game changer. So with that, what we say, the predictive maintenance transforms data into foresight. So Empire empowers missions to whisper before they roar. That means before missions are going to fail, they'll whisper, they'll inform you that something is wrong. So, and it makes a downtime is a choice, not as a consequence. Okay? So we can decide when to do the maintenance, rather than forcibly doing the maintenance. So that's what predictive maintenance is the future. I think many companies will adopt. They've already started adopting it. So what we call upon, empower your business with the foresight of tomorrow, experience the future of reliability and efficiency through Qritrim predictive maintenance. So I would request all of you to visit our site and look at our solution, reach out to us if you have any questions, any implementation need. We are there to help you. Thank you, guys. With this, I'll conclude and we can shift to the question and answer session.
Sure, Suman. Like we have a couple of questions here. So, like Hadi asked, how does Qritrim ensures the seamless integration of its AI and as a service platform, like the Cheif platform, with existing data integration and analytic systems in different industries?
Yeah, that's a good question, Shalini. So the way we have designed AI platform, the data input for the AI platform is configurable. Okay? So we have given multiple connectors. People can choose the connector and they can connect to that specific example. You are having all your data being stored. Your data warehouse is available in particular technology. Okay, so our system has a connector for that particular technology, and you can choose the connector and you can connect the data. So different companies might have stored the data in different technologies, and we have connectors for the most of the standard technologies. So that's how integration is smooth. It's just a drag and drop, a simple one. So hope that answers my question, your question.
Yeah, yeah. And we have another question. So it's from Siddharth. What industry-specific expertise and insights does Qritrim offer through its factoid solutions, particularly in the context of electrical diagram extraction and documentation?
Uh, okay, that's a very good question, Siddharth. Actually, Kritrim, as such, uh, inbuilt, it has a capacity to learn the domain-specific knowledge, but the domain-specific knowledge must be fed. Okay? So as Kritrim gets expanded into the newer domains, Kritrim starts acquiring that knowledge. Okay? So example, Kritrim was implemented for the predictive maintenance for the automotive solution, automotive factory, automotive manufacturing factory, and their primary need is for the electrical diagrams. Okay? But the same solution can work for even other equipments also, not only electrical equipment, it can work for even the mechanical equipments also. So as we feed uh, other domain information, Kritrim will start acting as per the domain. Okay? So, but the good part is that it has the inherent capability to learn. Okay? Hope Siddharth, that answers your question.
Well, I hope that answers the complete question. And we have one more question posted asking can generative AI be incorporated into the PDM process and how they contribute to improving maintenance outcomes?
Yeah, that's a very good question. Because we have we have a root cause detection and as well as a recommendation system to fix the given problem. So there we can incorporate LLMs, generative AI, because generative AI and LLMs are very powerful in understanding the existing documents, primarily FMEA kind of documents or mission documents. So definitely we can incorporate. Right now we have done on our own way. So we built a knowledge base, knowledge out of it, uh, and from that knowledge we are doing the recommendation. I think the possibility could be to see to put LLMs and see how they perform and combine LLMs with some knowledge graphs and see how they perform. But definitely a potential opportunity to integrate generative AI there.
Well, that's all about questions, Suman. So, any more questions? Your questions are welcome. And yeah, if not, then that was the session was very insightful. And thank you so much for joining us and sharing us these insights, Suman. Thank you so much. And anybody wants to connect with us, then they can connect with us at connect@twitter.com. And thank you so much for the day. Have a great day.
Thank you guys. Thank you very much for your time. Thank you.
Thank you.